Right, so today we're going to talk about symmetry. What does it mean to carry a shape onto itself? Just means that the shape has symmetry. The different types of symmetry we have are line symmetry, rotational symmetry, and point symmetry. And line symmetry is where a line can be drawn so each point is reflected in that line. So for one, they want to know how many lines of symmetry there are. So here they kind of have this line drawn in here, and it would be the same if I folded this A on this line. So that would just be one line of symmetry. For 2, Z, I can't fold it in half vertically or horizontally or diagonally. So there would be 0 lines of symmetry. For the butterfly, I could fold it in half vertically. So that would be 1 line of symmetry. 4 looks like it's pretty close if I would try and fold it in half this way, but if you notice this comes to a point here, so if I would reflect that, it would have to come to a point here, and it doesn't. So if I try and look vertically or horizontally, that's the same issue I have, and I know I can't cut it in half diagonally, so this would have 0 lines of symmetry. For 5, for this flower, I would have 1, 2, 3, 4, 5 lines of symmetry. And then, oh, I need one more. There's the 6th one because I counted this one already. So that would be 6 lines of symmetry. For 6, I could fold it this way, I could fold it this way, and then I could fold this both diagonally, so that would be 4 total lines of symmetry. 7 with the parallelogram, if I tried to fold it in half this way, it's not going to line up. If I try and fold it in half diagonally, that's not going to line up. And if I try and fold it in half horizontally, that's still not going to line up, so that's going to be 0 lines of symmetry. And 8 with this triangle, that's going to be 0 lines of symmetry. So for 9, we're supposed to shade this figure so it has exactly 1 line of symmetry. So basically they've started a shape and we have to finish it so it would have 1 line of symmetry. So if I wanted this to have just 1 line of symmetry, I'm going to say I want to be able to fold it in half vertically like that. So if I fold it in half this way, in order to have this match up, I'd have to shade in this side over here. But I have to be careful because if I would fold it up and down like this, then it would still match. So I'm going to go ahead and shade in this top corner on both sides, because then that makes it so I can't shade it, I can't fold it horizontally. I can just fold it vertically. 2, they want it to have 2 lines of symmetry. So I think with this one, if I just shade on this side, I could fold it this way and I could fold it this way and it would match. 11 wants 4 lines of symmetry. So I know to get my 2, I can shade in this one here. So that would give me my horizontal and vertical lines of symmetry. And then if I try and shade this, fold it diagonally, that would mean that this one here would have to be shaded and this one here would have to be shaded. And then that would give me my 4 lines of symmetry. And then this one, they started it off differently. So if I wanted to shade this so it has 4 lines, well, I'll go ahead and finish this one. So I'm good there. And if I fold it this way, diagonally, I would need to have this one shaded. And then if I folded it vertically, oh, I need this corner over here shaded, and this corner over here shaded. And then if I fold it horizontally, that would match up. So that would work. So that's for reflections. Next, we are going to do rotational symmetry. And we have a figure is the image of itself under a rotation about a point. So So if I rotate the figure and it turns out looking just like it started with, that would be rotational symmetry. To find the angle of rotation, basically that's just the smallest angle that maps the figure onto itself, excluding angles of 0 degrees and 360 degrees. So if I have to rotate it 360 degrees completely around, we would just say that the order is 1. There's only one shape there. Otherwise, depending upon how many times we can rotate it, depends on what the order is. So if we could rotate it twice, it would have an order of 2. If we could rotate it 4 times, it would have an order of 4. And the order of rotation symmetry is the number of positions in which the object looks the same. So for problem number 13, we have this circular shape here. So to me, it looks like because of these 3 dots in the middle, I could rotate it once, twice, and then 3 times to get it back to where I started from. So to find the angle, I would take 360 divided by 3, because my order was 3. It took me 3 times to get it back to where I started. So 360 divided by 3 is 120 degrees. For the S, for number 14, I think this is the same if I have it right side up as if I have it upside down. So that would be once, and then twice to get it back to where I started from. So that would be an order of 2. And so to find out what my angle is, I would take 360 divided by 2, which is 180 degrees. For 15, with these arrows, this one I think I can turn it once, twice, and then the 3rd time gets me back around to where we started with. So that would have an order of 3, and then I would just take 360 divided by 3, which gives me 120. For 16, for this parallelogram, if I start it here, it takes me until here before I have it so it's the same again. So that would be once, and then back all the way around would be a second time. So my order is 2. So I take 360 divided by 2. That would be 180 degrees. 17, we want to shade this figure so it has an angle of 180 degrees and an order of 2. So basically I want it to be the same right side up as it is upside down. So right side up, this right side is shaded. So if I rotate this upside down, I need to have this right side shaded. So I'll go ahead and shade that in. And that's it. For 18, we want to have an order of 4, so I have to move this 4 times. So if I start here to move it once, it would be here. So I'd have to shade in this right side. And then 2, shade in this right side. 3, shade in this right side. And then 4 puts me back to where I started. 19, we want to shade it so it has an angle of 180 degrees or order of 2. So I'm noticing it's the top right and the middle box. So if I flip this around, I'd have to have the top right and the middle box shaded. And so if I flip it back around, that would be my order of 2. 20, we want to shade it so it has an order of 4. So since it's the top right and the middle, if I go once, this would be the top right and the middle. I'll go another time, so I need the top right and the middle. I'll go another time, be the top right and the middle. And then back to where I started from. And that would be my order of 4. So next, for point symmetry, Point symmetry exists when a figure is built around a point such that each point has a matching point the same distance but in the opposite direction. So that's what they're trying to indicate here is this distance is the same, it just went in the opposite direction for all of these. That's all that they're saying. So what I do is I just use a simple test to see if it has a rotational symmetry of order 2. So basically, if it's the same right side up as it is upside down, then I know that it has point symmetry. So up here with these that we were doing up here, if I looked at for 13, if I looked at this one, right side up versus upside down, that's not the same, so this does not have point symmetry. But for 14, this S, it's the same right side up as it is upside down, so this one would have point symmetry. So I could say this would have point symmetry. This parallelogram one would have point symmetry. For the ones that we made, all of these would have point symmetry because they are the same right side up as they are upside down. So that's what makes them have point symmetry, because they're the same in, they're built around the same. And that is it for today. So you can use the rest of the hour to work on the homework.